Now that's poisoning. Poisoning is kind of exotic. Evasion is what most of us are going to do. There's going to be a model somebody else made, and we want to fool that model. And I don't know if you noticed, DEF CON and everything used to have these T-shirts and hats with the dots on them saying this will fool facial recognition, and people put some dots of makeup on their face to fool recognition, and that works. That's an evasion attack. So let's try a couple of these. So this is a simple three-way categorization task. And you make a support vector machine model to categorize them. And now we're going to make an evasion attack. Now here's an example. This is a image. They were sorting into different animal categories. It determined this was a panda with 57% confidence. Then they added less than 1% of this random noise, and now it's a gibbon with 99% confidence. And a human can't even see the difference. And this is the point. Remember, these machine learning models are not humans. They processed the pixels. They gave each pixel a weight. They chose some pixels of this image to be super important in making that difference, which are not the ones we would choose. So this modification completely fools the model. So we're going to perform that attack here, and this is where it calculates the where to move this dot to have the most effect. You move it from there to there, and that will have the largest effect, and you can then rate its accuracy, and you see its accuracy can fall down to chance with its sufficient motion there, and you can find which points to move and how far to move them with this model. So that's the abstract mathematical version. But for intuitive understanding, the visible MNIST one is the one that's the most fun. So we're back to this data of handwritten digits that we're going to categorize here. So there they are. We have 5s and 9s. We train a classifier to learn how to tell the 5s from the 9s, and then we perform an evasion attack, and here are the modified images. So this one is a 9, correctly perceived as a 9. This little bit of junk makes it think it's a 5. This junk makes it think it's a 9. It gets all these wrong, and that's the evasion attack. These little bit of snow that would never fool a human is enough to fool the machine learning model, because it looked at the parameters and it deduced that it was paying attention to those pixels, and a small change in those pixels would have a large change in the output. So that's evasion, and you can try smaller perturbations here and see what effect it has. There's different perturbation types to try, but just changing a few pixels is enough to confuse the machine learning model, because it's not doing what we do. And that's why, that's an important security issue. That's why I say the number one thing I'm always telling my clients is don't trust these things. You are being fooled into thinking they're smart. Humans down through history have had a pet goldfish and a pet animal and an idol they worship and stuff. You can see something that has no intelligence at all, and you will perceive your intelligence bouncing off it. You will project onto it the idea that it's a living, thinking being like me, and that's what's going on. You read a page of large language model text and you say, oh, this thing is smart. No, you're smart, and you're seeing your intelligence in that output. The actual model is stupid. Anyway,